In this example, we're given a rational function, a fractional function. We're asked to find the intervals, the x intervals of increase and decrease for this function. You can go back and review the definition of increasing function and decreasing function. We just are asked for an open interval of x values. We don't need closed brackets, just open brackets on the sides. These are the values of x for which the function, the y partner, is getting higher and higher and higher, or lower and lower and lower. Now, first step we have is step 1. We're going to find the first derivative with respect to x of this given function, f prime of x. Well, I'm going to rewrite it so I can use the product rule instead of the quotient rule. So I'll write it as parenthesis x fourth plus 1 parenthesis times x to the negative 2. Now, after I've rewritten it, I'm assured to use the product rule. I like the product rule better. So taking the derivative, well, actually, before I even do it, I'm going to distribute multiplication instead of using the product rule. I get x to the 4 minus 2, which is x to the second, plus 1 times x to the negative 2. Great, now I just use the power rule. Now take the derivative of f prime of x is equal to 2 times x to the first minus 2 times x to the negative 3. Those were two applications of the power rule. And then I wrote it as 2x minus 2 over x cubed. Now I'm going to simplify this f prime of x and factor it. F prime of x is equal to, let's see, I can write it as 2 times x to the fourth minus 1 over x third, and then I can factor x to the fourth minus 1 as a difference between squares, and then factor again, and I'll get what you see there, 2 times x squared plus 1 times x minus 1 times x plus 1 over x cubed. Okay, so I've simplified and factored. Now I'm going to use the real critical numbers of f to partition the number line. You can review this idea in note 67. The critical numbers of the original function f are found by setting the derivative f prime equal to 0 and solving. Once again, critical numbers of function f are the zeros of f prime. Okay, so we have f prime factored. All we need to do is well, it's more than that. It's also the values of x for which the function's f prime is undefined. So if we set the factors in the numerator and the denominator equal to 0 and solve for x, we'll have all of our critical numbers. We get 1, negative 1, and 0. And 0 is the x value at which the function f prime of x is undefined, while the 1 and negative 1 are the values of x where the function is equal to 0. F prime is equal to 0. They're all critical numbers. Step 3, find the signs, either plus or minus, of the slope of the tangent, f prime of x, in other words, in each of the regions. Okay, so we're going to do a sign graph. I'm going to write f of x. Oh, is it f of x I want? No, that should be f prime of x. So please correct that. Step 3, it's f prime of x is 2 times x squared plus 1 times x minus 1 times x plus 1 over x cubed. Here's my number line of x's. I'm going to partition the number line with the critical numbers negative 1, 0, and 1. Now I'm going to figure out what the sign, positive or negative, of the f prime of x is in each region. Each factor gives me a plus times a negative over a negative. And together, that will give me a negative result for those. Okay. For the next region, choose a value between negative 1 and 0 and look at the sign of each factor. There's a plus times a minus times a plus over a minus. Multiply that together, you get a plus for the entire f prime of x. And then between x values 0 to 1, choose a value and see the signs are plus, plus, minus, plus, plus on the bottom, and when you multiply you get a negative for that region. And finally, for x values greater than 1, plus times plus times plus times plus over plus gives you plus. Okay, so step 4, I'm going to sketch the slope in each of the regions of the tangent. So the slope is f prime of x. When it's positive, the slope of the line makes it lean to the right. When it's negative, the slope of the line of the tangent line makes it lean to the left in each of these regions. Well, in the first region, we have a minus sign, so I'm going to draw a line that's leaning to the left. That's the slope of the tangent. Then positive leaning to the right, negative leaning to the left, positive leaning to the right. Okay, that's really easy to do. Step 5, make a conclusion. Okay, the conclusion is that the function is increasing on the interval of x values from -1 to 0, union together with 1 to infinity. And it's decreasing on the interval from -infinity to 1, union together with the interval from 0 to 1. Those are intervals of x values. And you can just look at the graph we drew and see that that's true.